Hello everyone, and welcome to part 2 of Beyond Square Roots, Multiplying, Dividing, and Rationalizing the Denominator. Now again, we went over a few things in the first video, so let's take a look at that. Now again, remember, when we multiply radicals, we break down the radicands, we pull the perfect groups, multiply the whole numbers and pool the radicands together, and then pull perfect roots again. So what changed? Again, as we look at everything, what really changed for us is right here. The index of the radical we now have to watch out for because of the fact that this is no longer going to be assumed to be 2. We're going to see something else there. So we have to be more careful. Alright, so for our example, okay, so first thing we're going to do, again, as we use our steps, is we are going to break down the radicals. So again, let's start. 12 we know is 4 and 3. 4 breaks down as 2 times 2. So I have 3 cube roots of 2 times 2 times 3. Okay, 24 I know is 8 and 3. And again, if you've watched my videos before, a shortcut for breaking down 8 is 3 2s. So 2 times 2 times 2 times 3. And 54 is 9 times 6. 6 is 2 and 3. 9 is 3 and 3. So we have, forgot the index here, cube root. So we have cube root of, we have 1, 2, and we have 3 3s. Okay, well, let me zoom out a little bit here so we can have some more room. Now, again, remember what to watch out for. The index of the radical is 3, which means I'm looking for perfect sets of 3's in this case. Now in this first parenthesis, I don't have that, so I can't take anything out. As tempting as it is to say, well, what about the 2's? That would be true, remember, if we were dealing with an index of 2 or a square root. So since I don't have a 2, I have a 3, I can't take anything out. So 2 times 2 times 3. Okay, now here I can take out a perfect group of 2's, because that's a set of 3. So I multiply these guys together, I get 4 radical 3. Okay, well, let me get rid of that. And bring it back in. And then here, I've got a set of 3's that can come out. So I'm going to have 3 cube root of 2. Again, it's very important we don't forget the indexes of the radical. Okay, like I just did. Now, from here, let's start to multiply. Now remember, when we multiply, the regular numbers we're going to multiply regularly. So 3 times 4 is 12. 12 times 3 is 36. Cube root. Now we're going to pool all the radicands. So I've got 1, 2, 3 2's. So 1, 2, 3 2's. And I've got 2 3's. So 3 and 3. Okay? Now, to finish this thing off, what we're going to do is, again, pull our perfect groups. Well, again, I've got a perfect set of 2's. It's going to kick out. So 2 times 36 is 72. Cube root. Now, these guys I couldn't make a perfect group with, so I'm going to multiply them, put them back, and we get a 9. And that is our solution. All right, and again, it's awfully tempting to try to take out that 9, but remember, we're dealing with a cube root, not a square root. Alrighty, folks, here's our next one. Now, I remembered this time to put in our steps, just in case you missed them on the last one, and that's okay. Alright, so again, first thing we'll do, let's break down the radicals. But again, we're going to keep in mind that I'm dealing with 4th roots this time. So here we go. 2, now 9 I know is 3 times 3. 4, don't forget the index. 4th root of 6, now again that doesn't go very far, but again 2 times 3. And then 4th root of 12, now again 12 you break down as 4 and 3, and 4 is 2 times 2. So 2 times 2 times 3. Alright. So then our next step, again, is we're going to pull our perfect groups, if I have any. Well, here I don't have a set of 4. Here I don't have a set of 4. And here I don't have a set of 4, so I can't pull perfect group. So now let's multiply everything together. Now remember, on the outside of these radicals, there are 1's hiding. So 2 times 1 is 2. 4th root. Now again, I've got 1, 2, 3 2's, so 2 times 2 times 2. And I've got 1, 2, 3, 4 3's. 1, 2, 3, and 4. Okay? So now I'm going to pull my perfect groups. Now again, the only perfect group I have, because I'm dealing with an index of 4, is this 3. So I'm going to kick that out as a 3. So 3 times 2 is 6. 4th root of, now 2 times 2 times 2 gives me 8. And we're done. All right, now this one, believe it or not, is a trick question. Does anyone see why? Let's see. Why is this a trick question? Well, the key is the indexes 2, 3, and 4. Again, we cannot, in this state, multiply radicals that have different indexes. We'll have to use something called fractional exponents, which we haven't gotten to yet. So currently, this one can't be done because of the different indexes. All right, let's look at this next one. Now again, remember folks, whoops, that doesn't look good. There we go. Now remember folks, that when I'm dealing with cube root, I can have a negative under the radical. It's going to kick out as a -1. So first thing I'm going to do is I'm going to take out the -1, so I don't have to worry about the negative anymore. All right, so we're going to have, when we break this down, -3 cube root. Now 16 is 8 and 2. We know 8 is 3 2's. With another 2 gives me 16. Okay. 4 we know is 2 2's. And 6 we know is 2 times 3. So we break down the radicands. All right, our next step, let's pull perfect groups if we can. Well, here is a set. I can kick out a 2. In this group, I can't take anything. In this group, I can't take anything. So now my problem says I'm going to have -6 cube root of 2 times 2 cube root of 2 times 2. Again, we don't put it back yet. Cube root of 2 times 3. All right, now let's pool all this stuff together. Now again, regular numbers multiply regularly. Okay, so -6 times 2 is -12, times 1 is -12. The radicals, we pool, so we got 1, 2, 3, 4 2's, so 2 times 2 times 2 times 2 times 3. Okay. Now let's pull our perfect groups again. Now again, whoops, forgot the index. Because the index is 3, I'm going to take out a perfect group of 2's, because I can. So 2 times -12 is -24 cube root. And what's left over inside the radical is 6. All right. Now again, when reviewing dividing radicals, again, it's the same steps as before. The only difference is we have to watch out for the index of the radicals. All right, so let's take a look at this one. Again, I'm going to make it a little smaller so I have the room to work. All right, so here we go. Let's start by breaking down the radicands. So 3 cube root, and 10 is 2 times 5, over 2 cube root. Now 18 is 9 and 2. 9 is 3 and 3, so 3 times 3, oops. Should do the smaller numbers first. Let me fix that. Okay, so we do 2 times 3 times 3. All right, next step, pull perfect groups. Well, I can't. Reduce whole number to whole number and radical to radical. Well, the whole number is obviously 3 and 2 I can't reduce. But when I look under the radical, I can take out a set of 2's. So that'll make my life a little easier because now I don't have to deal with that. Okay? Multiply, well, this isn't a multiply problem, so I don't have to worry about step 4. Reduce if possible, we can't, but now, here's the problem. We now have to rationalize the denominator, because remember, we cannot have radicals in the denominator of a fraction. Now before, when we dealt with square root, the trick was multiply by the radical itself. Problem is that won't work this time because our index is not a 2. So we have to think in terms of creating our perfect groups. And again, if you watched my videos before on radicals, I did say, don't think in terms of the trick of just giving another one there. Think in terms of completing perfect group. Now here, I've got 1, 2 3s. So I would need one more 3 to complete my perfect group, because I'm working in sets of 3 according to the index. So what happens in the bottom now happens to the top. Okay? So let me get rid of that so it doesn't confuse people. So now, let's multiply. So we're going to have 3 radical, now 5 times 3 cube root 15, over, now this creates a perfect group, so it's going to kick out of the radical as a 3. So you're going to get 6 now on the bottom. And our last step says to reduce again. Well, I can reduce the whole numbers. This drops to 1. This drops to 2. So our answer would be 1 cube root of 15 all over 2. And yes, for those of you wondering, you do not need the 1 there. So if you want to make it go away, you can. So there is your answer. All right, let's look at another one. Now again, we have to be careful. Now I'm going to scooch this over here so I have some room to work. All right, so here we go, folks. Start by breaking down the radical. I'm going to have 2 fourth root. Now 6 is 2 times 3. Now again, it's awfully tempting here to say, well, 4 is underneath here. That's a perfect group that kicks out as a 2. But again, realize we're working in index of 4. Not square. So this, believe it or not, is not a perfect grouping because we need a set of 4. Okay? So let's start off. Can I pull perfect groups? No. Can I reduce the whole numbers? No. Can I reduce radical? Yes. I can take out a set of 2's. So this and this is now gone. Okay? Multiply, well, this ain't a multiplication problem, so reduce, don't have to yet. Rationalize the denominator. All right, here we go. Here's the fun stuff. Okay, so I'm just going to grab this and move it, oops, down here. Don't mind the little circle on the right. All right, now, again, think in terms of completing a group. Fourth root. All right, so here we go, folks. I've got 1, 2. I need 2, 3, 4. I need 3 more 2's to complete a perfect grouping. So 2 times 2 times 2. 2 times 2 times 2. Okay? So now let's put this all together. So 2 fourth root of, I'm going to multiply this up here all together. So 2, 4, 8. 8 times 3 is 24. All over. Now this right here creates a perfect group. It's going to kick out as a 2. And then our last step, reduce again if possible. Well, I can reduce these guys right here, and they may cancel off, leaving you with a final answer of the fourth root of 24. And there it is. All right. I'm going to let you try this one on your own. Let's see how you do. I'm going to scooch that over there, though. Okay. So I'm going to let you try this one on your own. Let's see how you do. I'll come back in about a minute, and let's see how you did. And again, remember, folks, you can leave the video running. So I will come back in about a minute. Alrighty, folks, I'm back. Alright, so here we go. First thing we do, break down the radicals. Well, radical 2 I can't do anything with. Radical 3 I can't do anything with. So, can't break down the radical. My next step, pull perfect groups. Well, 2 is all you can do, 3 is all you can do, there's no perfect group. Reduce whole number to whole number and radical to radical. I can't do that either. Multiply, well, again, this isn't a multiplication problem. Reduce, couldn't. So we're already at step 6, and I haven't even done anything yet. All right, so here we go. We drag, whoops. Grab the wrong thing, here we go. So let's grab this. Okay, now again, realize we are dealing with cube root. So, in order to do this, let's think in terms of perfect group. I've got 1 3. I need 2 more 3's to create a perfect grouping. So 3 times 3. 3 times 3. Okay? So now let's multiply this together. Whoops. Hold on a second. I made a mess. No. Alright, here we go. We'll have to deal. Cube root. Alright, so again, let's put this all together. So 3 times 3 is 9, times 2 is cube root 18. On the bottom, again, we've got a perfect grouping here, so it's going to kick out as a 3. Now it says to reduce if possible. But again, remember, this right here is a radical. This right here is a regular number. We can't intermix the two. Therefore, this is your final answer. All right, give you another one to try. Let's see how you do. Again, you can leave the tape running. I'll come back in about a minute and let you try this out. Alrighty, buddy, I'm back. So the first thing I'm going to do, I'm going to scooch this over here so I have some room to work. Alright, here we go. Let's break down the radicals. On the top, we have 4, 4th root. Now 6 is 2 times 3, over. Now 32, 3, 4th root. Now again, if you break down 32, 2 and 16, 4 and 4, 2, 2, and 2 and 2. So we have 1, 2, 3, 4, 5 2's. 1, 2, 3, 4, 5. All right. So now my next step says let's try to pull perfect groups. Now on the top, I don't have anything. But on the bottom, I've got a perfect set. So let's get rid of that. Let's kick that out as a 2. So we have 4, 4th root of 2 times 3 over 6, 4th root of 2. All right, so far so good. Now my next step is to reduce whole number to whole number. Now here I can reduce by 2, make this 2 thirds. 2 thirds. I can also reduce the radicals, radical and radical, which nicely enough in the bottom, that goes away. 4th root 3. Multiply, well this ain't a multiply problem. Reduce, can't. Rationalize the denominator. Now again, notice this time, folks, there's no radical in the denominator, therefore there's nothing to rationalize. So, don't have to worry about that. And reduce one more time if needed. Well, we don't have to. So, this guy right here is your final answer. All right, now here's where we're going to introduce more of step 4 and 5. because now we have multiple fractions going on here. Okay, let me scooch that up, shrink this down a little bit because I'm going to need a lot of room for this one. All right, so here we go, folks. Let's break down the radicals. I'm going to bring it over here. So 2 cube root. Now again, 6 is 2 times 3. 5 cube root. 8 is 2 times 2 times 2. 12, I know is 4 and 3, and 4 breaks down as 2, so 2 times 2 times 3 over cube root. Now 28 is 7 and 4, so 2 times 2 times 7. And then we have cube root 7. Cube root, now 10 is 2 times 5. All right, so there's part 1. Break down the radicals. Now our next step says we got to pull perfect groups. Well, here I've got nothing. Here I've got a perfect group, so let's kick that out of there. 2. So I'm going to need to start my parentheses. 2 cube root 2 times 3. Multiply these, I get 10. Okay, here I've got nothing. So again, working on that top piece, again, I don't have anything nice, so cube root 2 times 2 times 3. And on the bottom, again, nothing there, so cube root 2 times 2 times 7. 7. There we go, finally made the 7. And then from here, cube root of 7's got nothing. Cube root 2 times 5. Okay, now, so we pulled our perfect groups. Now let's pull this, let's try to reduce. Now remember, we can reduce up and down and diagonal. And diagonal does not mean right next to each other. They can be one piece over. So for instance, like this 2 and this 2 are technically diagonal, so I can cancel them. Okay, so I'm just going to go down the line. 3, I don't have any 3s. I can cancel a set of 2s. Another 2. I can get the 7s on the diagonal. So this goes away, this goes away. So now, I'm going to pool everything together, right? So again, on the top, regular numbers I'm going to multiply regularly. So 2, and that's it. So 2 cube root. Now, rad 3 and rad 3 I'm going to pool is rad 3 times 3 over. Now here I got 10 cube root 5. Okay. Take the tail on that a little bit. Now, our next step is to try to reduce again. Anytime you multiply at radicals, you should always try to reduce again. So again, the 2 and the 5 I can. 10 I can. Okay, let's scooch this down a little bit. So I'm going to get cube root 3 times 3 all over 2 cube root 5. Alright, now I have to rationalize the denominator. Okay, now again, realize I'm dealing with a cube. I've got 1, 5, 2, 3 makes a perfect group. 5 times 5, cube root, 5 times 5. Alright, so let's pull this all together. 5 times 5 is 25, times 3 is 75, times 3 one more time gives us 225 under the radicals, so cube root 225. Now on the bottom, we're going to create a perfect set. Kicks out as a 5. 5 times 2 is 10. Now our last step, try to reduce if possible, but we can't. So there's your final answer. Alright, I'll let you try this one on your own and see how you do. I'll give you about a minute. You can leave the video running, and I will come back. Alright, here we go. Now again, noting I'm dealing with 4th root. So first thing I'm going to do is make this smaller so I have some more room to work. Alright, here we go. 4th root of 3. Nothing happening there. 4th root of 2. 6. Again, I can break down as 2 and 3. And 9 is 3 and 3. Oh, that doesn't look like a 3. Let me fix that. There we go. And here, 2, 4th root of 2 times 5. 3, 4th root, and again, we all know 8 is 3 2s. Alright, so there's my first one. Now my next step, let's try to pull perfect roots. So this has nothing, this has nothing, 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 nothing. So nothing going there. So let's pool everything. We'll multiply. Remember, there are 1s hiding in front. So 1 times 1 times 2 is 2. 4th root of. Alright, I've got 1, 2 2s. I've got 2 3s. And I have a 5. On the bottom, I have 1 times 3, which is 3. 4th root. I have a 2, 2, 3, 4 3, or 4 2s, I'm sorry. And I have 2 3s. Alright, so let's try to reduce, make our lives a little easier here. So I can take out a 2, take out another 2, take out a 3, take out another 3. So now I'm left with 2 4th root of 5 over 3 4th root of 2 times 2. So now, at this point, let me get that tail off. Now we got to rationalize the denominator. Alright, 4th root. 4th root. I've got 1, 2 2s, and I need 4 of them to make a perfect grouping. So 2 times 2, 2 times 2. Alright, so let's pool this, multiply it. So 2 4th roots, 5 times 2 is 10, times 2 is 20, over, this creates a perfect grouping, kicks out as a 2, so it's 6. And then our last step, try to reduce, so I can reduce these guys to 1 4th root of 20 all over 3. And again, for those of you who are wondering, no, you don't need the 1. So there you go. There's that one. Alright, again, let's give this one a whirl and see how you do. Again, leave the tape running. I'll give you about a minute to work on this one, and then we'll come back and talk about it. Alrighty, so let's begin. I'm going to, make that smaller. Apparently these aren't all one piece, so I have to put that together. Alright, here we go, folks. So, 3 cube root 2. Break down the radicals. 2 cube root 3. 6 cube root 2 times 3. 2, and again, 8 we know is 2 times 2 times 2. Here, cube root 12 again is 4 and 3. 4 is 2 and 2, so 2 times 2 times 3. And 24 is 8 and 3, so 2 times 2 times 2 times 3. Alright, let's try to pull perfect groups. This has nothing, that has nothing, this has nothing. This has a perfect grouping, so let's kick that out as a 2. Oops, I should have been writing this down, hold on. Now I gotta catch up. 3 radical 2, all over 2 radical 3. 4 radical 2 times 3. Oops. Need the index to be correct. 3. There we go. Now here I could take out a perfect grouping. That makes a 4. Now on the top, I've got nothing, so cube root of 2 times 2 times 3. Here I can take out a perfect set of 2's. So you get 2 cube root 3. Alright. Now, our next step is try to reduce up and down and diagonally here. So, let's see. I can get 3 and 3. Look at that, radical's gone. That's nice. Okay, I can get 4 and 4. I can get these radical 3's here. Okay, and I really can't do much of anything else. It's awfully tempting to say, well, what about these guys? But again, they're on the same level. That's not up and down or diagonal. Okay, so let's pool these guys together. Okay, so I get 3 times 1, which is 3. Cube root, I've got 1, 2, 3, 4 2's. Okay, on the bottom, I've got 2 times 2, which is 4, and no radicals, which is really nice, because now, reduce, can't, rationalize, there's no radical to rationalize, and reduce one more time, can't, so, oh, wait a minute, I'm sorry, we forgot to put all this, we could pull perfect group, I'm sorry, kick that out as a 2. Some of you are probably screaming at me here. Alright, let's try that again. So yes, we can pull perfect groups. So, kicks out as a 2, so 6 cube root 2 all over 4. And then, now we can reduce. So 3 cube root of 2 all over 2. And now that would be done. Alright, give this one a shot. I'll give you about a minute, and then we'll talk about it. Alright, here we go. Let's start. Here, we'll shrink this so we get plenty of room. Alright, here we go. 2 fifth root of 6, 2 times 3. Over, now 12, fifth root. It's going to be 2 times 2 times 3. Fifth root, now 16 is 8 and 2. So that's 2 times 2 times 2, that's 8. Give me one more 2 is 16. 24 is 8 and 3, so 2 times 2 times 2 times 3. Fifth root, now 32 is 8 and 4, so 2 times 2 times 2 is 8, with 2 times 2 is the 4, that's 32. Fifth root 18 is 2 times 3 times 3. Alright, our next step, pull perfect groups. So this has nothing, that has nothing, This is close. It's got 4, but not all 5. Nothing. 1, 2, 3, 4, 5. Here's a perfect pair, or perfect set. Kicks out as 2. Like so. So yeah, let me catch up. 2 fifth root 2 times 3 all over fifth root 2 times 2 times 3. Here, fifth root 2 times 2 times 2 times 2 all over the fifth root 2 times 2 times 2 times 3. 2 over fifth root 2 times 3 times 3. Alright, so this is where we stand right now. So let me scooch this down. So our next step, try to reduce. Let's make our lives a little easier here. So up and down and diagonal. So get the 3's. Take out a set of 2's. So this radicals are gone. 2's on the diagonal. Okay, so this radical's gone. That's nice. Here I can do a 2, 2, 2, and that appears to be it. Okay, so now let's start to pull this together. Now again, realize this radical's gone, these are all gone. So 2 times 2 is 4 over, I have just radicals left on the bottom, so 3. Oh, that's not a 3, that's a 5. Sorry, looking ahead of myself here. Fifth root. Okay, so we have a 2. I have 1, 2, 3, 3 3's. Alright, now, here's where it gets fun. Now we have to create our groups, our perfect group. Now here, I've got 1, 2. I'm dealing with fifth root. So I need 2, 3, 4, and 5. I need 4 more 2's here. So 2 times 2 times 2 times 2. Now here I've got 1, 2, 3 3's, which means I need 2 more 3's to create my fifth. So 3 times 3. So fifth root, 2 times 2 times 2 times 2 times 3 times 3. Alright, let's pull this all together here. On the top, okay, you have 4 fifth root, 2, 4, 8, 16, 48, and then 48 times 3 is 44, so 144 over. Now again, here's one perfect grouping, so that's going to be 2 times, let's do this a little separately, and I have this perfect grouping, so times 3. Okay, 4 fifth root 144 over 6, and now let's reduce 4 over 6. I can reduce to 2/3, so whoops, 2 fifth root 144 all over 3.
I'll be back in a second.
Yep.
Oh, cool.
All right, so while I'm watching her bag, you guys can be working on this problem. So again, give this one a shot. I'll give you about a minute, and then we'll go from there. All right, we are back. So let's do this one up. Okay, so let's start off. Break down the radicals. Cube root 2 times 2. Bottom cube root is 2. 10 is 2 times 5. Okay, cube root 6 is 2 times 3. 15 is cube root of 3 times 5. 18 is cube root of 2 times 3 times 3. And 75 is 3 times 5 times 5, because it's 25 times 3. Alright, so we have that. So our next step, let's try to pull perfect groups. So this has nothing. Okay, that has nothing, 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 and nothing. So I don't have to rewrite this one this time. So now let's begin. We're going to pool this all together. So on the top, no regular numbers on the outside, so I can go straight to the radical. I've got 1, 2, 3, 4 2s. 3, 4 2s, and I've got 1, 2, 3 3s. 3 over cube root of 2 times 3 and 3 and 5, 5, 5, and 5. 5, 5, 5, 5. Alright, now let's scooch this over a little bit here. Alright, so let's try to reduce, make our lives a little bit easier. So I've got a 2. I've got a 3. I got another 3. I don't have any 5s up top. Okay, so we reduced. So our next step, let's pull our perfect groups. Here I can kick out a 2. So 2 cube root 3 on the top. On the bottom, we've got a set of 5s that can come out. So 5 cube root 5. Now, the problem is, I still have a radical in the denominator. I got to fix that. So let's clear this out. Okay. So again, I've got 1 5. To complete my cube root, I need 3 of them. So I need another 5 times 5. Cube root 5 times 5. Okay, so let me scooch this down a little bit. Alright, so let's do this up. 2 cube root, now 3 times 5 times 5 is 75. Over, now this creates a perfect grouping, kicks out as a 5. So 5 times 5 is 25. Oops, a little dash in there. Let me get rid of that. There we go. So again, then see if we can reduce one more time, but we can't, so there it is. Alright, so that's the end of the video. So hopefully you learned a lot. And again, stay tuned. We've got plenty more coming. So good luck out there.